Hello, my name is Harmony Hardy. I'm the builder for the team. I assembled the parts and structures to create the machine.
Hi, I'm Marisa, and I am the lead programmer. I designed code that allows the machine to move and function accordingly.
Hi, my name is Kathleen. I researched the advantages and disadvantages of different types of materials and tools that were incorporated.
Hello everyone, my name is Khadija. I worked as the lead designer, so I worked from designing the initial sketches all the way to helping work with the layout.
Our machine utilizes renewable energy through rechargeable batteries that help power the conveyor belt. All the components we used were repurposed, and the net cost of the project was $0. In addition, the dimensions of the machine were less than 35 by 35 inches.
Our device is designed to clean land areas along Baltimore's Inner Harbor, working with existing trash wheels in Chesapeake Bay. Urban debris has caused an estimated excess of 3 million pounds of trash littering the streets and getting into the bay, which is home to over 3,600 species of plants and animals, and contaminated water presents a constant threat to their habitats.
However, our machine aims to mitigate this issue by intercepting as much trash as possible before it even reaches water sources, thus safeguarding the bay from pollution.
We implemented a slope design on the conveyor system for the device's automated movement, which is powered by VEX robotic motors. This inclined structure efficiently lifts the trash, ensuring it is deposited into the designated bucket. The slope surface guarantees that all collected trash is centralized in one area. We decided to place the motor on the top side because we didn't want them to interfere with the motor's use for the wheels. For the wheels, we decided to use a singular motor to limit energy consumption. The motor is placed above the wheels so that they do not touch the ground.
We mainly conducted research on VEX robots as the majority of our team was unfamiliar with them. We were given VEX parts to repurpose, so we needed to understand how their wiring and mechanics worked, especially for regearing the motors. In addition to that, we spent time looking at precedents such as the trash wheels mentioned previously. We also looked at the mechanisms of different cleaning robots like Roombas to find things we thought we could recreate at a larger scale to facilitate a wider range of use.
Based on the principles of material conservation, reusing is far more efficient than recycling since it saves energy of having to dismantle and manufacture the product. Recycling also consumes substantial amounts of natural resources and financial investment, whereas reusing eliminates the excessive use of water and air. With this in mind, we developed our projects with the objective of eliminating the need for new purchases and instead focusing on repurposing resources already provided within our school environment.
We decided to repurpose VEX robotic parts previously used by our school's robotics teams, in particular those parts that are in deteriorating condition and aren't efficient for use. This included damaged wheels, rusted shafts, pulleys, conveyor belts, and even used motors. Our goal had leftover popsicle sticks from a prior project, and we used these leftovers to make the machine's walls. Our school also had Arduino boards, which are over 10 years old and were no longer in use, so we decided to incorporate this into our project as well. For construction paper and the tape that was used in our project, we borrowed these materials from our school's origami club, which allowed us to develop this machine with a net cost of $0.
We explored numerous concepts, discarding many along the way. Initially, we had thought that a functioning hatchet would have been good at guiding the trash, but through trial and error, we felt it was best to have the conveyor belt with added cleats. Another challenge arose with the motors we initially purchased, as they didn't integrate well with the VEX pieces we had in place. We ended up discarding the motors and repurposed one of the old VEX motors that our advisors did not need anymore.
After our first design, we modified the cleats on the conveyor belt because they were made out of rubber, which is too fragile and led to inconsistent trash collection. So we instead replaced them with popsicle sticks that were much more durable, and we also constructed a wall for added stability.
We used popsicle sticks on the conveyor belt so that items could be held while going up. The popsicle sticks were also long enough to accommodate items of varying sizes, ensuring that the machine could handle a diverse range of test subjects. We recognize that small pieces of trash may potentially fall off the conveyor belt, so we addressed this issue by constructing a cardboard slope and attaching it to the back of the conveyor belt.
Along the way, we have gained a better understanding about persistence and resilience. At the beginning of our project, each step seemed to backfire as we discovered how little detail is very important to the development of our project. For example, we originally had purchased a different brand of motors, and we were thinking that it would help solve the stability problem within our machine. However, the motors were very weak and unable to spin our wheels. By seeking help from our advisors and also researching on our own, we were able to find old VEX motors that were not used, so instead we repurposed them to stabilize and move the machine. We learned that effective communication, dedication, and reattempting to solve the problem at hand are vital skills to the success of any project.
This is the code for our machine made on Robot C, which allows the motors on the wheels and conveyor belt to move using a touch sensor.